Hello everyone, we are live again in our live version of the AI Talk. Today we will be discussing something very interesting. First of all, let me give you a little bit background on these tech talks. These tech talks are more or less based on the questions that we on the Skive side got from you and as well as from our team. And these are totally unscripted, so whatever you asked, I'm here to answer those questions. So today our focus is very much on how to get AI to think out of the box. Put it in simpler sense, how can we make our AI systems better in what they're doing and how they're doing? Most of the time when we interact with AI, it's based on some sort of data that's driving that AI system. Is that always needed? Is that the right strategy? And what we could do to make AI to think much more like us? Can AI have common sense? And all these questions falls under one domain when we talk about AI. How are we building the AI system? So just as a background, a very specific field in AI is deep learning. And if you look at a lot of the intelligent AI systems, deep learning is the core. And there are different ways to go about deep learning. Broadly, there are two categories: supervised learning and unsupervised learning. Most of the time, when we're talking about data and using data to train a deep learning system, you're talking about supervised learning. So you have a huge amount of data. It could be your viewing habits. Could be your viewing habits. It could be the things that you browse. And that data, along with the history of data, is used to train AI-based recommender system. So when you go to Netflix, it will recommend you movies based on what you watched. That's usually based on supervised learning. Sometimes these recommender systems are also simply using pattern matching or some sort of machine learning. The second system is about unsupervised learning, where you're not providing trained or tagged data. So you're not training the system based on data that you collected in the past, but the system is learning as you go. And that's what unsupervised or self-supervised deep learning algorithms is. And with this, based on this specific background, let's touch upon our first question. Our first question is how would engineers or developers balance the suggested content and outside interest of users, since products recommend specific content to users? And this question very specifically relates to how is the system built? Is it using AI or is it not using AI? Is it using some sort of pattern matching machine learning technique, or is it using something more than that? If we are talking about a trained system, either a supervised deep learning system or a system that's based on some sort of modeling that was done in the past, then it is possible for your deep learning system to figure out things in advance. And in other words, that's how an engineer or a developer or even a data scientist who's modeling or building that system can predict what it will recommend, how it will recommend. That changes a little bit when the systems become to some extent self-aware, which means is that when the system learns based on pre-existing data, and that's what happens in supervised learning, where you provide a lot of data, train the system, and then you take that system and deploy it in production. And that's where the system will definitely give you answers. Once you deploy the system, most of the time it's out of the hands of engineers or developers. The second system I mentioned to you was the unsupervised, or sometimes it's called the self-supervised learning system. A simple technique for such systems are reinforcement learning systems, where a good example is you get a robot to go from point A to point B, or you get a robot to play a game, or you get a robot to open a door, but you don't tell anything to the robot. His goal is just to open the door or win the game. And the robot will try many times, thousands of times, millions of times, and will learn on its own. And by that way, it becomes intelligent. It's finally able to win the game. All they tried a million times. In those sort of system, it's less realistic for a data scientist, a developer, or an engineer to have too much say in what the system will actually recommend. So the good thing is that the system is learning on its own. It's based on raw data, less human intervention. And to some extent, that will result in systems that have what we humans have, common sense. On the other hand, if the environment for that system or that AI system or some of the variables of the AI systems are not clearly defined, you will result in something we all know about, biases. The system may not give you right results. The system may not even give things that you were expecting because the system is learning on its own. So there are pros and cons to both these systems. So supervised, untrained raw data versus unsupervised raw, untrained data versus supervised, very structured, tagged data. In the past, till today, most of our emphasis has been on these trained model. There's a training phase and then there's an inference phase. You train the model based on a lot of data. But as we go ahead, I don't believe that will be the case. We'll have more self-supervised or unsupervised learning systems in our lives. That could be in form of robots, that could be in form of recommender systems, that could be in form of how our cars operate in the future, or how our planes fly. The most fascinating thing about self-supervised learning or systems that learn on its own is this idea of getting an AI system to learn on its own is not new. I still remember a paper that I read from the past, which was on Alan Turning's systems about Turing machines, and it was, I believe, in 1950s, if I remember right. And Alan Turing mentions that let's get AI systems to learn how kids learn. And decades back, we are at this position, and our systems are based on that. Okay, so that was a little bit of a long answer. We have another question, and the other question is, as the developing process of AI is evolving at fast pace in recent years, how long do you think this process will take to reach the step where they finally have the ability to think outside the box, to think above the other possibilities and interests that its users might be interested in by interacting with them instead of purely suggesting the contents the users are interested in by utilizing its own algorithm? That process actually has already started. If you look at how self-supervised learning and unsupervised learning are being used, yes, the number of those systems are low, but they are still being used. There are some ethical issues that are under play, as well as some compute issues that I believe will be resolved sooner. On the ethics side, we have many organizations, both government and private, working on those Even on the Skive side, we are working with some of our friends at the UK side on building regulations around AI. On the compute and system side of things, I believe we are already at a state where we could use these self-supervised learning systems. And once you have these, that's when the whole essence of getting a machine or getting an AI system to think outside the box, which is machines to have instincts or machines to have intuition or common sense. The process to get to those systems have already started. It's just for us to work on these systems, building more robust systems, and also working not just in the technology aspect of how these systems operate, but what can these systems do and don't? Where should these systems be used? Will you want to use a autonomous self-supervised learning system in a killer robot? Probably not. It's not really needed. You do want to have human in the loop in those cases. You could still use drones for defense purposes as long as there's a human in the loop. The other aspect about robot companions, which is something we on the Skive side are working on, and we call those systems Robometrics machine. Those are a great use case of self-supervised learning algorithm or system, because what's really missing in AI today is common sense, intuition, machines that could actually feel as opposed to just acting as something that are much more superhuman. We want robots to be more human. In terms of the interest of the end users, which is people like you and me, where these AI systems will be interacting with us, it's a double-edged sword. Just like you have a coin, which a fair coin will have two different sides of the story. The good part is that some of these systems could really help for use cases. For example, we on the Robometrics side are working on robot companion for the aging population. That's a critical use case today. The other side of that is also true. If these systems are not engineered correctly, they could very well recommend things that are, yes, out of the box, but that are not in the right interest of the end users. Interaction with some of these systems sometimes may even be harder if they are not working in the right way. And we have cases in the past where some of these chatbot systems, I remember there was one by Microsoft which got haywire and was providing answers that was just not correct. So that's what I will actually say, that the process has started. I believe we need more companies, more organizations, and especially public sector organizations to play an important role. And they should know that these systems are already there. The technology is there. Companies are working on that. And the government agencies needs to work with us on the private sector side with the same goal, which is to help end users. These are some of the things that we have been working here on the Skive side. We have been working on building the core AI technology. That's one. We are also working with lawyers and policymakers on regulations around AI. And we're not just thinking about what's needed right now, today, but what will be needed in the near future. What if the cars comes to level 5 where they could drive themselves, or when these robots are much more self-aware, they have consciousness, for example. And the third thing is we are also working on really getting these self-aware autonomous AI systems in commercial use, ranging from general aviation to healthcare. I mentioned to you about robot companions for aging population to autonomous cars. It will be really boring to sit in a level 5 autonomous car when the car drives itself and you're not doing anything. And lastly, we are also working on a smart home use case. How can your homes be self-aware using some of the technologies that we are building? Let me take one more look if we have any other questions. I believe that's it. So we had 2 questions. These are 2 great questions. Just to summarize, we covered 2 different flavors of AI systems. One that learns on its own, or which are self-aware, and this other one which are trained, or which learn based on tagged data. And both these systems are possible today. The latter, which is data-driven AI systems, is much more prominent. They're much more well-known and much more studied. On the other side, self-aware, self-supervised, or unsupervised learning algorithms are much less known and less used. And as the world go forward, as we evolve as human species, we'll see more and more of these unsupervised, self-supervised learning algorithms and systems that are based on these algorithms. As always, I'm here. Please feel free to reach out to me or any one of my team members. You are welcome to message and connect with me on Facebook or LinkedIn or any one of our team members. It was great to have you. We will have one of these very soon again. And in the meantime, any burning questions, please feel free to get in touch with one of us, including me. Thanks. Bye.